Students, let's discuss exercise 7.4, sixth sum. The vertices of a triangle ABC are 4, 6, 1, 5, and 7, 2. A line is drawn to intersect sides AB and AC at D and E respectively, such that AD by AB equal to AE by AC equal to 1 by 4. The ratio is 1 by 4. Calculate the area of the triangle ADE and compare it with the area of triangle ABC. So recall converse of basic proportionality theorem. So first we must know that the converse of basic proportionality theorem. The theorem says this: if the line segment, okay, in the triangle divides these two sides in the same ratio, we can say that this line segment is parallel to the third side. So the line segment in the triangle, it's divides the two sides in the same ratio. Okay, these two sides. Then this line or line segment is parallel to the third side. Actually, that is the converse of basic proportionality theorem. Okay, so that is only the question also given. At the same time, the similar triangle property we studied in this ninth standard. The square of the ratio between the two sides will be the ratio between the square of these two triangles, the triangle ABC and the triangle ADE. Okay, so the side square, the ratio of the side square equal to the area, the ratio of area of these two similar triangles, the triangle ABC and the triangle ADE. Okay, by using this concept here we are going to find out their area. So here directly given the area of, the ratio of sides of triangle is 1 by 4. So already we know that if we take the square of the ratio, that is the ratio of area of two similar triangles. So 1 by 4. If we take the square, 1 by 4, the whole square is 1 and 4 square is 16. So this is the ratio between area of two similar triangles, 1 by 16. Students, let's discuss exercise 7.4, 7th Roman 5th subdivision. If ax1 y1, bx2 y2 and cx3 y3 are the vertices of triangle ABC, find the coordinates of the centroid of the triangle. So students, first you know that what is meant by centroid. The centroid means that is center. So here the centroid of the triangle is in which point the three medians are intersecting. In which point the three median of a triangle intersecting, that is centroid. I hope you understood what is meant by centroid. So these are the 3 points A, B, C. Here I took the centroid as O. So to find the centroid, so first we need to draw the median from A to the sides BC. Next from B to the side AC, from C to the side AB. Here I am going to find from the vertex to side BC. So here first we need to find out the midpoint of BC. So what is the midpoint of BC? How to find out? X2 plus x3 by 2 comma y2 plus y3 divided by 2. So already you know the midpoint formula. At the same time, from the diagram see this, the centroid dividing the median into 2 is to 1 ratio. So the ratio is 2 is to 1. Then here I am going to use that section formula. So already you know the section formula, mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. By using that formula, here I am going to find out the centroid. So already we know that here which is x2, the x2 is x2 plus x3 by 2, and x1 here which is x1, that vertex A is x1. So we know the ratio m equal to 2 and n equal to 1. So substitute the formula. So m into x2 plus x3 divided by 2 plus n into x1, n into x1, 1 into x1. So divided by m plus n, 2 plus 1, comma 2 into y2 plus 1 into y1. So 2 into y2 plus y3 divided by 2 plus 1 into y1 divided by 2 plus 1. So here 2 will be cancelled. So remaining x1 plus x2 plus x3 divided by 3, and here also 2 will be cancelled. So remaining y1 plus y2 plus y3 divided by 3. So the centroid of the triangle is x1 plus x2 plus x3 divided by 3 comma y1 plus y2 plus y3 divided by 3. So to find the centroid of the triangle, you can use this formula. Students, I hope you all understood this concept. Actually, this is the formula for finding centroid of a triangle. Students, let's discuss exercise 7.4. 8th Roman. ABCD is a rectangle formed by the points minus 1 comma 1, b minus 1 comma 4, 5 comma 4, and 5 comma minus 1. P, Q, R, and S are the midpoints of A, B, B, C, C, D, and D respectively. Is the quadrilateral PQRS a square or rectangle or rhombus? Justify your answer. So first we know that square, if it is square means all the sides should be equal. At the same time the diagonals also equal. The rectangle means opposite side should be equal, and then the length of the diagonals are equal. Or rhombus. Rhombus means all the sides should be equal but the length of the diagonals are not equal. So here first we need to find out PQ or S. Okay, so already given these are midpoints of the sides. Okay, so first we need to find out P. P is the midpoint of AB. By using midpoint formula we need to find out P. Then similarly we need to find out Q or S. Thereafter, finding the PQRS, we need to find out the length of the sides, length of all the sides. Thereafter, we need to find out the length of their diagonals. So let's find the side P. So see here. So the coordinate of P is we found by using midpoint formula minus 1 comma 3 by 2. So similarly we can find out Q or S. So Q is 2 comma 4, R is 5 comma 3 by 2, and S is 2 comma minus 1 respectively. So already I told we need to find out the length of PQ, QR, RS, and SP. So the length of PQ is we found by using the distance formula. So square root of 61 by 4. That similarly the length of QR is also 61 divided by 4, and the length of RS is square root of 61 by 4, and the length of SP is square root of 61 by 4. And the next we need to find out the diagonal. So the length of the diagonal PR is 6, and the length of the diagonal QS is 5. So here see this, the sides are equal, okay, but the length of the diagonals are different. If the sides are equal but length of the diagonals are different, means we know that the shape will be rhombus. Okay, so we know that the PQRS is a rhombus.